The most important part of trigonometric substitution is the translation of the given algebraic integrands into the trigonometric form. So we have to remember that we can perform trigonometric substitution if we see the patterns a squared plus u squared, a squared minus u squared, or u squared minus a squared. Wherein, if we have a squared plus u squared, we let u equals a tangent theta. If we have a squared minus u squared, we let u equals a sine of theta. And if we have u squared minus a squared, we let u equals a secant of theta. So before we solve fully using trigosub, let us first learn how to translate from the algebraic integrand, from the algebraic form into the trigonometric form. That's the new part here in the lesson. So suppose we want to evaluate the integral. Okay, we want to evaluate the integral of the square root of 9 minus x squared dx over x squared. So this dx here is not under the radical sign. Okay, so first is, do we see any of these patterns ba? So for this item, we have 9 minus x squared, which follows the pattern a squared minus u squared. Okay, so let's write that. 9 minus x squared follows the pattern a squared minus u squared. So that we can say that a squared is equal to 9, so that a is equal to 3, and that u squared is equal to x squared, and that u is equal to x, and then unsa naman, dili na ta mangita sa du. Instead, we substitute na. So we let x, which is our u, we let x be equal to a sine of theta. So what is our a? It's 3. So we let x equals 3 sine of theta. And so, diha na ta mag-differentiate. Dx equals 3 cosine theta d theta. So guys, do not interchange the integration rules with the differentiation rules. So if you are to differentiate sine, it is positive cosine. Okay? So this is now equal to the integral of the square root of 9 minus, so what is our x? What is x? Because we are now going to replace this with theta. So x is equal to 3 sine theta. So 3 sine of theta quantity squared. And what is dx equal to? What is dx equal to? Dx is equal to 3 cosine theta d theta. Okay? So 3 cosine theta d theta over, what is x squared again? That's 3 sine squared, or 3 sine of theta quantity squared. Okay, so we have now the integral of the square root. Okay, the square root of 9 minus 9 sine squared theta. Okay, 3 cosine of theta d theta all over 9 sine squared of theta. So natay makancel here nga cancel nga 3. So 3 na lang ang mahabilin sa ubos. And then under the radical sign, we can factor out 9. So integral of the square root of 9. We're doing this step by step so that you can see clearly how it's done. 1 minus sine squared theta. Okay. Cosine of theta d theta over 3 sine squared theta. So under the radical sign, we have 1 minus sine squared theta. But what is 1 minus sine squared theta equal to? That is equal to cosine squared of theta. Ba? That is cosine squared of theta. And then cosine theta d theta over 3 sine squared of theta. Okay, to continue, extracting the square root, we get 3 cosine theta and then times cosine of theta d theta over 3 sine of squared of theta. So we cancel out 3 and then multiply the two cosines. So we have cosine squared theta d theta over sine squared theta, or that is equal to the integral of cotangent theta d theta. So that is the translation from the algebraic form to the trigonometric form. And then after that, you can now proceed to evaluating the, by the way, that is squared, evaluating the integral using any of the other methods discussed. Okay, let's try another number. Let's try another item. Okay, we want to translate the integral into the algebraic integral into the trigonometric form. Let's try the integral of dx over x squared, x cubed, square root of x squared minus 9. So this time, this is u squared minus a squared. So if u squared minus a squared, we're going to use the function secant. Alright? So our a squared here is 9. And so our a is 3. U squared here is x squared. So u is equal to x. So we let x equals 3. This time it is secant of theta. And so dx is equal to 3 secant theta tangent of theta d theta. So substituting, this is dx is 3 secant theta tangent of theta d theta over, that's x raised to the power of 3, but what is x equal to? It's 3 secant theta, and we're going to raise that to the power of 3 and then extract the square root of x squared, which is 3 secant theta quantity squared minus 9. Okay, so that's the integral of 3 secant theta tangent theta d theta over 27 secant cube theta square root of 9 secant squared theta minus 9. So that's now the integral of, we are able to cancel secant here, and then 3. So what's left in the numerator is tangent theta d theta, and then we divide 27 by 3. What's left is 9. Cancel out 1 second, so we have secant squared theta, and then we factor out 9 under the radical sign. We have secant squared theta minus 1. So tangent theta d theta over 9 secant squared theta, extracting the square root, or let's just extract the square root later. That's 9. But then secant squared theta minus 1 is tangent squared theta. So that's the integral of tangent theta d theta over 9 secant squared theta times 3 tangent of theta. So we are able to cancel out tangent. So that's why we have 1 over 27 integral of d theta over secant squared theta, or that is equal to 1 over 27 integral of cosecant squared theta. Cosecant, it's secant squared theta. Cosine, rather. Cosine squared theta d theta. So that's the translation from the algebraic form to the trigonometric form.